In today's class, we will look at an interesting problem that has been studied extensively: pipe flow. A pipe is a tube-like structure which is used to transfer fluid from one location to another location. From an engineering point of view, we want to minimize the amount of energy that is spent in moving the fluid from one location to another location. In other words, we want to minimize the pumping cost. The amount of effort spent in moving the fluid depends if the flow is laminar or turbulent. A famous non-dimensional number that is used to characterize the flow regime is the Reynolds number. It's non-dimensional because it does not have any units. When fluid flows through a pipe, there is pressure drop along the axis of the pipe. Let us say you want to transfer water from a local pond to your house. And let us assume that there is a smooth pipe which takes water between these 2 points. Now what happens if I replace this smooth pipe with a rough pipe? Example, a pipe made from cast iron. Now there is going to be additional pressure loss because of more friction. This means your pumping cost is going to go high for achieving the same flow rate. A German engineer named G.H.L Hagen in 1839 measured the pressure drop that occurs across a brass pipe through which water is flowing. The dimensions of the pipe are shown on the screen. He performed this experiment at different inlet velocities and came up with the following plot. Now this plot is very interesting, and let me just walk you through this plot. In the x-axis, I'm plotting the velocity through the pipe in feet per second. And in the y-axis, you can find the pressure drop that occurs across the pipe. For lower values of velocity, the pressure drop is small and the relationship between pressure and velocity is almost linear. When the velocity reaches a critical value, which is 1.1 feet per second in this case, there's a sudden change in slope. Now, for this particular value of velocity, if you calculate the Reynolds number, it's around 2300. From fluid mechanics, you would have learned that when Reynolds number is greater than this value, the flow becomes turbulent. And hence, from an engineering point of view, what we learned from this graph is, when the flow becomes turbulent, the pressure drop across a pipe is going to be more, which means the pumping cost associated with this is also going to increase. Solving simple correlations like this actually helps you understand the topic better. This graph was made using Octave. Let us take a look at the script.